And now I'd like to introduce Dr. Sang Wong Kim.
Thank you, Tracy. Let me also extend my welcome to everyone who is joining us today. As we begin our webinar, I would like to introduce my co-speakers. William Peng is an associate consultant based in our Boston office. Einar Svensson is a principal with SDG based in our Dusseldorf office in Germany. And I'm also pleased to welcome Leandro Basilio, founder and CEO of Deep Seed Solutions, upstream digital solutions provider. Thank you, gentlemen, for joining us today. We want to begin our webinar with a polling question. Is your organization using artificial intelligence to conduct business? Perhaps you're an advanced user using it systematically already, or occasionally only by certain individuals. Not using it now, but has a plan to do so in the near future, or don't have such plan. Please select an answer and click submit. While we wait for the polling to close, I would like to bring up one of my speakers. Einar, you work with a set of clients in a variety of different industries. What has your experience been in your clients adopting artificial intelligence to what they do?
Yeah, I think I see it probably most frequently in a bit of an exploratory phase where the companies may have efforts running to explore and evaluate the potential benefits of AI programs to improve or optimize certain systems or products. And then they would be looking into sort of making decisions around which of these programs to have and fund and so forth. But beyond that, of course, we see everyone using GPT for everything. And some of the companies further along in utilizing in their operations.
Okay, good to know. I think I count myself as a user of ChatGPT as well.
Guilty.
It looks like we're getting the responses. Shall we go ahead and close the poll? Thank you. Okay, so well, I guess about 40% is either using it systematically or using it occasionally by a certain part of the company, or do not currently use it, but has a plan to do so in the future. Very good. When I think of energy transition as a decision analyst, I think of it as an interaction of decisions made by 5 main parties. At the core of it is a transaction between providers who provide energy to a set of consumers who need such. For example, we may want to charge our phone, which needs power, or fertilizer companies would need natural gas to make their products. Because energy consumption is such a basic tenet of our economic activity, there is a role for government or policymakers to play, such as setting rules in terms of how much these services need to be charged at, and we're setting regulations to make sure to control the impact on the environment. We need advancements in technology to make energy transition possible towards a lower carbon world or economy. Whether it is making existing technology better, such as making batteries, or investing in forefront of the technologies such as direct air capture. This will help both the consumers to use our energy better, more efficiently, thereby reducing emissions, and also helping energy producers produce their products better and decarbonize their products. I think we can all agree that achieving the goal of reducing carbon emissions would take enormous amount of investment. So that also means we need people who are willing to make investment regardless of the nature of the products, the project or investment, but to make a financial return from it. In fact, many of the energy producers and technology providers have partnered with external financiers to invest in the technologies and bring the decarbonization solutions forward. Getting back to the topic of the day, which is exploring the intersection of artificial intelligence and energy transition. I want to make a case that AI plays a very interesting role with respect to energy transition. As William will share with us in a second, it has already resulted in more efficient use of energy, meaning AI, which helps us reduce our energy consumption, thereby reducing carbon emissions. At the same time, these powerful chips and data centers to enable the advancement of artificial intelligence, it takes an enormous amount of energy. They are much more power intensive than their predecessors, which means AI is also a major consumer of energy in respect, especially power. And somehow we need to find ways to meet that incremental demand from the evolution of artificial intelligence. And there is a concern, at least in the near term, how quickly we can scale up our energy infrastructure to meet that demand. And perhaps in the near term, it may result in more carbon emissions because we need to advance AI solutions. So today we'll talk about the dual aspects of artificial intelligence and what as decision makers can do as industry players in embracing AI solutions in advancing energy transition or addressing the challenges. I will now turn it over to William so that he can tell us about those dual aspects of AI and energy transition.
Right, thank you, Sang-Won. As mentioned previously, AI is a powerful tool to enable and accelerate energy transition. And in fact, organizations are already seeing tangible results from AI when it comes to climate actions. A recent study actually shows that organizations that have implemented AI for sustainability have managed to reduce greenhouse gas emissions. They have managed to achieve cost savings and improve power efficiency, all by some 10%. What's more interesting on that is energy organizations, amongst all other participating organizations in this study, report a higher net gains than average across these three buckets. So looking ahead, the potential of AI in energy transition is even more promising. These organizations are anticipating that AI will bring at least the same level of impact to their organizations in terms of energy efficiency, cost savings, and emission reduction over the next 3 to 5 years. Here are some examples of energy companies integrating AI to drive their energy transition journey. For example, Shell has achieved 20% time savings by using AI to enhance subsurface data analysis. Another example would be Enel uses AI for its renewable asset bidding forecast, leveraging AI's predictive capabilities. And this leads to a substantial reduction in terms of imbalanced costs. Of course, there are way more examples out there in the world of companies leveraging AI in their energy transition journeys. This all showcase the ability of AI to optimize renewable energy operations, drive cost efficiencies, and ultimately accelerate energy transition. So what on earth are AI's capabilities and applications? When it comes to energy transition, AI acts as a technological force across 4 overarching pillars of use cases. The first one is analytics and forecasting, which is the most common one that you see. AI leverages existing data to enable predictions and forecasts, and generate insights to drive strategic decisions for both operators and executives. Another one is to optimize energy operations at every level, from asset maintenance to grid management. AI can achieve this by, let's say, automating routine tasks, monitoring performance in real time, and facilitating predictive maintenance to maximize operational efficiency and at the same time minimize costs and downtime. Coming down to number 3 here, AI can manage different energy systems at scale. And this involves integrating diverse energy sources and manage distributed energy resources. And this is crucial because, first of all, it addresses fluctuations in energy generation and also ensures stability of infrastructure for energy companies. The last one relates to research and innovation. AI can accelerate innovation cycle and unlock new possibilities by driving advancements in, for example, renewable technology, scientific research, and even collaborations across different entities across the globe. And collectively, all these four pillars of use cases represent the potential of AI in reshaping the energy transition landscape. Again, as technology advances, they will drive further innovation, efficiency gains, and sustainability across the energy sector. Now let's talk about the other side of the story. Not only generates insights, but also generates emissions. But as you probably already know that AI's emissions are largely coming from data centers, which is a critical piece for training AI and use AI. And if we have to analyze and quantify the emission a data center generates or produces, it is simply how much carbon it generates to generate the power for data center times the total amount of power a data center consumes. It's a simple equation there, but there are more drivers behind these two elements. The carbon intensity is largely dependent on the source of energy and geographical locations. What kind of energy do you choose to power your data center, and where do you choose to get that energy? Both have different implications in terms of carbon emissions. Now coming down to the second part, which is how much power does a data center actually consumes? And these are largely driven by three things. The first one is power efficiencies of data center. Again, geography plays a big role here in terms of bringing different weather conditions that have a strong impact on a data center's cooling capabilities. But what's more important is the power efficiency of equipment. And this includes both non-IT equipment and IT equipment. IT infrastructure, for example, like a GPU, and a non-IT infrastructure simply as a light bulb for the data center. Fairly speaking, a GPU designed for AI consumes more power than a regular GPU that we use on other data centers for servers or even on your own computer. But OEMs like NVIDIA are coming up with chips that are more power efficient, have more power, have more power, computing power, and use less power. Now, the second part of that driver is how much computing power is needed, which is driven by two things. The first one is end user adoption and usage. How many users are there actually using artificial intelligence, and how frequent their usage is? The second part is the level of complexity of AI models that goes through the data center. Generally speaking, the more complex the model, the more computing power it actually requires, and that will translate directly to the power demand, and AKA electricity. Now, coming down to the last one, which is the size of data center. This is usually represented by the number of servers a data center contains. Well, AI is typically built upon a data center type called hyperscale, which typically contains 5,000 servers, which is a large number and a lot more compared to other types, for example, an enterprise or a mini data center that used solely by one company. Now let's talk about the scale of emissions AI actually creates after talking about all the different drivers Well, US currently has a third of all data centers in the world, and that makes it the largest data center market in the world. And in 2022, just in the US, these data centers consume about 17 gigawatts of electricity. And to put that number into perspective, that would require 34 large gas-fired plant or generators to meet this demand. In addition to that, this number will double in the next 6 to 8 years. And this will translate to about 113 million tons of carbon dioxide emissions just from data centers, just from the US in a single year. And again, to put that number into perspective, again, that will be equivalent to an annual emissions from about 10 million US households. So essentially we're creating 10 million US households in the US in that single year, but virtually. So the question then becomes, how do you meet this demand that has gone up so quickly, that has gone up so big? And perhaps more onto that is, how do you meet this demand in a greener and cleaner way? Perhaps it is easier to say, well, let's build more nuclear generators or more wind farms, but that is not going to happen in a very short period of time or without a significant investment. So the current solution might be that we have to utilize different resources and capacities to generate this amount of power to meet this demand. Well, actually, energy companies, they are already taking actions and making significant investment to combat the challenge of soaring energy demand here. For example, We Energies, they just announced that they are going to spend $100 million on a project to serve Microsoft's new data center. Other companies are either seeking to build more capacity or delay retirement of their existing assets. We see many utility companies here, but because they're just at the forefront of customers, but eventually it will have a ripple effect and impact the entire energy sector overall, both upstream and downstream. Again, the challenge for those organizations is, how do you manage and find the balance between meeting energy demand from this data center and meeting your own net zero targets? And this becomes even more severe given the pressure from customers and regulators. So with all that said, it is extremely important for energy transition practitioners to make the best decisions in order to navigate the opportunities and the costs. Now I'm going to hand back to Seung-Hwan to talk about the decision perspective.
Of course, I better be heard. Thank you, William, for uncovering the opportunities that AI brings in advancing energy transition, and also how much electricity is actually needed to meet the needs of the AI revolution, and thinking about its opportunities actually for utility companies. I've heard recently from somewhere the current explosive growth in energy demand caused by AI revolution is something that's comparable to wide adoption of air conditioning from back in the 60s and 70s. That's quite remarkable. I also would imagine that you talked about it being equivalent to 10 million new US households. I would presume that there's a large range of uncertainty around it based on those factors you have laid out in terms of the energy intensity, carbon intensity, size of these, and then perhaps decarbonization solutions. So we want to bring back to the decision side. So we talked about this intersection of the AI and energy transition. Before doing that, we want to ask you another question. What do you think are the biggest challenges in integrating AI in energy transition? Not knowing enough about what those capabilities are, and having enough resource to integrate them. You're not sure about whether it could be successfully deployed and you will get the return on the investment, or there are just simply too many cases or applications to choose from, or you're actually concerned about AI could increase carbon emissions from its when we start adopting it as a part of energy transition. Please let us know your thoughts. You can select up to 2 responses and please click submit. While we wait for the polling to close, I would like to bring another speaker to the table. Leandro, your company brings these AI solutions to the oil and gas industry and helping them make better decisions. What has your experience been like in helping your companies in adopting advanced solutions?
All right, so thank you, Sangwon. So the introduction of artificial intelligence in the oil and gas industry is relatively recent, becoming more relevant in the last 5 years. So the experience I faced developing AI for oil companies has been successful in the R&D centers inside those companies, where we've been receiving, very strong support on both technical and financial side. However, the deployment of the technology after they are, ready to be used, so across the operational units has been challenging in some companies, mostly due to cultural aspects associated to the introduction of a completely new way of doing their jobs. That in some case, kind of job that has been done based in people's knowledge for more than 1 century. So definitely for me, a cultural aspect is definitely the challenge to be faced.
Thank you. Leandro, let's close the poll and share the results. Oh yeah, it's interesting. Okay, all 5 choices were valid, I suppose. Got good responses. It looks like most of the challenge come from whether there's enough resource and capability to use them effectively, and then whether we'd be actually successful, and then knowing more and better understanding of those capabilities. Let's move on. So I want to bring back to the importance of decisions. So in doing so, I want to use some examples of the well-known companies, first in the energy sector, how they lead energy transition. And I would make a case that they do that by making strategic decisions. Let's take a look at the example of Occidental Petroleum. Oxy, better known, is the first company with its headquarters in the United States that declared that they will go to net zero, including scope 3 by 2050. They in fact declared themselves as a carbon management company based on decades of experience in CO2 enhanced oil recovery, where they need experience in capturing, transporting, and injecting CO2. They have been very consistent from early on in investing in one of the most advanced technologies in carbon capture, which is direct air capture. And in fact, they put their money behind their strategy by acquiring a company of carbon engineering last year. What do you think these milestones have in common? I would make an argument that these are a set of decisions or series of decisions that company has made, in most cases without having complete information about how technology will evolve or the market will behave over time. When they made early bets about direct air capture, which folks will still consider as early stage technology where there are a lot more to be done, they did not know that US Department of Energy will come out with a program to provide funding to help and advance those technologies. And they don't know quite yet how quickly this technology will come down on the cost curve over time. I would call Occidental Petroleum as a consistent early adopter, and they have been making series of decisions on investing in early stage technologies in advancing energy transition. Let's take a look at another example of ExxonMobil. It wasn't that long ago, the company was somewhat criticized for not making enough investment in the area of low carbon projects and decarbonizing their portfolio. Look at what the company has accomplished in the last few years. It was the first company in its Permian operation to declare that they will reach net zero through scope 2 by 2030. That's only 6 years away. They announced that low carbon solutions would be one of their 3 major businesses. So this is a company that is the largest US-based oil company, along with their massive upstream portfolio and downstream and chemicals portfolio. They're saying they will make business and money from low carbon solutions as one of their business units. They're leading one of the world scale clean hydrogen projects in Texas. They're about to become a major producer in lithium, which of course is critical to battery manufacturing. And they're now the operator of the largest operator of the CO2 pipeline in the world with the acquisition of Denbury last year. What you notice is that Exxon may not move as quickly or may not be the first. But once they're convinced that there's an economic investment case to be made, they move in with a large scale, often very hard to be matched by their competitors. Its CEO recently said their identity is a molecule company, which I think sums up their competitive strength and strategy really well. Now take a look at the example of BP. BP was one of the first companies to declare their ambition to achieve net zero all the way to scope 3 by 2050. They certainly made a lot of investments and advances in the area of renewables and driving clean hydrogen projects. However, they also made some course corrections along the way as well. They're still investing significantly in their traditional fossil fuel-based portfolio, and they actually lowered their target to reduce their upstream production, which several years ago they talked about reducing their upstream production by 1 million barrels per day. They're scaling back on that, and they're also scaling back on the timeline to achieve their ambitions in carbon emissions. In fact, its company's CEO recently said they're most excited about the opportunities in deepwater Gulf of Mexico. What I'm trying to show is that companies that are at the forefront of this energy transition, such as BP, even them make a series of changes or a series of decisions and adapt to different business environment, trying to balance their portfolio with the traditional hydrocarbon business with the new energy and low carbon businesses. And these are a series of very well calculated bets that company has made. So I make an argument that energy transition is fueled and advanced by these series of strategic bets. And I bet we can find many more examples across different industries. Let's take a quick look at the AI world. NVIDIA pioneered making very, very powerful chips above and beyond the capabilities of their competitors. They did not know when they were relentlessly investing in making the world's most powerful and fastest chips, they didn't know how quickly AI revolution will catch up and when exactly their products will be demanded. However, it seemed like their investment has paid off handsomely by absolutely dominating in the market, and they look like a genius. Other well-known technology providers, technology companies are making their own bets. Alphabet owns the company that made AlphaGo, DeepMind Technologies, and have been focusing on developing their capabilities in enhancing their products and the solutions with AI, while Meta is one of its biggest rivals, has been very aggressive in pushing products out into the market that has been enhanced with artificial intelligence. These companies that lead the AI revolution, they play in a very different world from those energy companies that we have talked about on the previous slides, also make a series of decisions without having full set of information to advance AI solutions. That's what it takes to advance these transcendental, the social, the phenomena. And coming back to this intersection of AI and energy transition, which is the topic today, we have to answer a lot of these questions. And I would argue that these are a lot of decisions that need to be made. On one hand, William talked about all those opportunities that AI bring in helping us better advance energy transition. But there's a series of questions such as how much capital, which technology, how you integrate them. On the other hand, it presents interesting challenges from the increased emissions, increased power consumption and emissions, and how do we meet that demand from what sources and what kind of decarbonization solutions can we bring to manage those. At Strategic Decisions Group, we work with companies that are trying to solve these challenges. For ExxonMobil, we did a project in conjunction with Leandro's company, Deep Sea Solutions, in integrating AI-based solutions in their deep water development, concept select development decisions. For an energy company, we help them think about how to change or think about a different portfolio asset strategy for their generation assets. We also work with a large global shipping company that was trying to build a framework to help with their decarbonization decisions. We also know that artificial intelligence will play a critical role in helping these ships operate better and eventually resulting in the less carbon emissions. So we'll talk about a couple of those examples today. Deep water decisions, it's after decades of making them, they're still challenging. It requires cooperation among many different parts within a company, subject to biases, and it takes a long period of time to develop and evaluate even just several different development concepts. Leandro, I think we have an example where we help companies address these challenges. Oh, Leandro, you're on mute.
The experience with ExxonMobil was very interesting with the project that we deployed with them. Before I talk about the result that we achieved, it's important to highlight about how complex a offshore development is. It's a capital project, intensive capital project that normally require investment of an average about $5 billion, depending on the size. And without the AI, it's a process that involves several technical disciplines, from reservoir to production unit, passing through the well engineering discipline, the subsea engineering, topside facilities, flow assurance, and normally this process is highly non-integrated in linear, where part of the process delivers the constraint and input data for the coming one. So it normally takes about 9 months, requires those of highly qualified engineers, and deliver a very limited amount of alternatives to be evaluated by the board. And when we see this process as is, without the artificial intelligence, we see a lot of bias. So normally people tend to repeat the same solutions that worked for different projects, and they normally avoid to test different options and technology. It involves several high level of uncertainties that's carried along the process from the reservoir, passing through the asset development and flow assurance, so on. And the reliability of the cost data is also something very complex, because most of case the database from client becomes out to date quickly, and they don't have the process to, update it in the required time to develop the field. So those are some kind of challenge that we see in offshore field development. And when do we apply artificial intelligence in the process, we dramatically change this game, and we can see huge increase of efficiency in the process. Then we can happily identify several different alternatives additionally to those one that's normally evaluated by the team, and we can test multiple strategies combined, and after some round of simulations, we can quickly find and understand how the combination of the several different strategies perform in terms of economics. And this, in the right side of the slide, we can see a typical graph that we call as trade space exploration. In this graph, we plot all the technical alternatives that's generated by the AI, crossing KPIs such as CAPEX against net present value. We can cross CAPEX against carbon emissions or payback. We can cross wherever KPI you want to see, and you can quickly find what we call as optimized zone. So moving to the next slide, we can then, using AI, moving from a very mechanical way of doing the work to a strategic thinking way, where you can quickly identify how the combination of the strategies will perform, and then you can remove the strategy that's not performing very well and emphasize the ones that's generating value. And you can quickly find the alternatives that will perform and do in the best way, and you generate value to the project. So those are some numbers we've got from the experience with ExxonMobil. We saw a potential of increase net present value in 15%. Is in CAPEX, we see beside of this number that we captured. So we've been evaluating projects where we were able to save around 30% in CAPEX, depending on how much mature the project is when we start applying the AI. And we can increase dramatically the number of alternatives that's normally evaluated by the project team from some units to 1,000, and then we can mathematically increase the chance of get the most optimized alternative to develop the field. That's something we've got with this pilot we deployed in ExxonMobil together with SDG, and then it was an impressive example of how artificial intelligence can generate value in the process of energy transition.
Thank you, Leandro. It was an eye-opening application for sure. But let's move on to the other example. Einar?
Yeah, thanks, Singwon. Yeah, don't paste too much. So this is the case you mentioned before. So work we did for a U.S. utility company, refining their long-term strategy, but basically the power demand from AI data centers came in as a major consideration there. But to tell you a little bit about the work, if we start from the left-hand side, so we started basically with some scenario development to develop a shared understanding of how the future may develop, and also to help inspire some strategic alternatives for the company. And what we identified as the sort of key driving forces were load growth on the one axis, sort of how much power they would need to serve, and then also the penetration of renewables both on the grid and behind the meter, so sort of what they call the distributed energy resources. But then we went into sort of on the right-hand side thinking about what are the sort of key decisions that they need to think about for their strategy, more or less. And as you can see, one of the first ones there is load, and a key consideration there is all those data centers that had a desire to basically get power from them, and they saw a surge in this in relation to the sort of AI revolution. Among the other choices that were in consideration was what to do about their existing portfolio of power generation assets. So it's a combination of both hydrocarbon and green power plants, one way or the other, wind, solar, gas, and so forth. And they were considering sort of rebalancing that to some extent, sort of potentially selling some and for decommissioning and potentially buying power back from others. New generation would be things like adding some renewables and potentially also adding storage to balance the grid. And for the DER, so they saw basically, some of their customers basically want to have their own dedicated sort of solar behind the meter. Could they actually play a role there and maybe sell them those equipment? Rate design is maybe more into the details of how they bill their current customers. But I think let's maybe have a look at the next one. So what we did with them, basically, as we do with a lot of our sort of strategy and decision projects, is that we built a probabilistic financial model, and we started analyzing each of the current generation assets, sort of how basically what their NPV would be under uncertainty and how different risk factors would impact them. So if you look at the left-hand side, there is what we call a tornado diagram showing basically how the risk factors on the left could impact the value of this generation asset C, and beyond that also how it will perform on each of the four scenarios that we described before, sort of the four quadrants of that chart. And based on that analysis, basically we tried to identify what assets they really wanted to keep, which assets they could potentially improve in some way by mitigating some of the risks, and which were potentially candidates for sort of getting rid of one way or the other. But if we continue to the next slide, so what came out of all of this? So as I said, so we did the asset valuations that informed also some additional decisions that could be made, and sort of to improve the portfolio. And then we used our probabilistic financial model to evaluate different actions and strategies or overall strategies to improve for this company. Maybe what need to be explained here on the right-hand side is that, so this is basically a co-op company that's owned by a lot of power, basically wholesalers. So their goal is to reduce the wholesale rate that they can provide their owners with. And the example that you see here is basically one of the strategies involved these three key decisions: adding a battery at one of the wind assets, replacing one of the CC gas turbines with a different type, stopping life extension in another one. You can see sort of the triangles represent the expected value of doing that, so significant rate reductions, which is good for them. And they're also quite robust in the sense that you see the range of uncertainty in the bars around it. And then the strategy overall is shown there at the bottom. So quite basically the probabilistic model is able to tell you quite a lot about how these actions impact their portfolio. But if we sort of summarize the key strategic findings, and maybe to come back also to the AI part of this, if we look at basically maybe key strategic finding number 3, their sort of optimal targets for load diversification. So AI data centers were a different kind of load for them, but they have a lot of challenges in the sense that they would kind of need to build new power to satisfy them, and they have the risk that they actually are mobile and can move away, and sort of other considerations. So it wasn't sort of a home run with them. They're still exploring sort of more creative solutions on how to provide them with services or sort of with contracting that makes sense. But some of the other key findings there, of course, as we mentioned, sort of identifying what assets would it make sense for them to remove, what to add. There's some low cost options also because they work in more than one market, so they could tie into different grids. and basically giving them a better understanding of the future sort of markets and outcomes, what's vulnerable, where they need to pay attention, and so forth. But I think, given that I also realized we're slightly over time here, I'll pass it over to you, Simon, to wrap up. Thank you.
Sure. Thank you, Einar. So I think it's time to wrap up. So hopefully you took away our point about AI brings both opportunities to energy transition and also brings challenges as well. And the latter challenge is kind of a traditional challenge of how you meet the increasing energy demand, both how to control the emissions and the perhaps seizing that additional energy demand as an opportunity. I think that is kind of addressed by the example that Einar has gone through. So it's basically generation asset portfolio strategy for companies. But the other side, which is embracing AI as a solution to advance energy transition, we talked about the example of using AI-based solutions and making better deep water concept select decisions, which basically there is a way to come up with a practical approach to utilize AI where we can build a model or algorithm that can support even these really high bet, the large investment decisions, not just mundane day-to-day small decisions in utilizing AI. Hopefully, so those are the points. Some of them are perhaps well known, some of them may be new and interesting, and some of them you maybe just disagree with. We would love to continue the dialogue. I understand that there are a lot of questions that came to our way. We ran out of time in addressing those questions, so we will get back to you. And hopefully it was interesting content for you all. At this point, I want to turn it back to Tracy for wrap up.
Thank you, Sinwan, and thanks to all our presenters. If we didn't get to your questions, the speakers have agreed to review them and respond via email. And once you leave today's webinar, you will be directed to a survey on the presentation, and we'd appreciate your feedback. You'll also receive a follow-up email with a link to view the recording of today's webinar. And on behalf of the Strategic Decisions Group and our presenters, thanks for joining us today, and have a great rest of your day.